I took the initial 10 minutes to kind of introduce the conference and the various sessions. We have about 50 minutes. So what I'll do, use the first 20 minutes to go through a few models and the systems that we have, and to motivate what are the aspects that are the gaps that there are in these systems, and to motivate why we need like subsequent different types of model forms or systems. And while explaining that, I'll also try to introduce the type of in-house platform that we have built to make it easier, or rather help improve the productivity of the data scientists, product managers, and category revenue managers to do these experiments in a more agile fashion and derive benefits. So broadly, that I'd like to cover in that manner, maybe 20 minutes to motivation and all, and then the remaining 20 minutes. So just before I start, may I know a little bit about the audience in terms of like who would work in terms of predictive modeling, inference, predictive analytics, or data science? Got it. And who would also work on, or either work on prescriptive insights and modeling? Okay. And how many would work on decision systems, this pricing, personalization, recommendation, or selection? Got it. Okay, thank you. That context helps. So let me introduce a little bit about our group and the type of problems that we have. Most of you would have been already aware of MakeMyTrip brand. But it's just not MakeMyTrip. We have MakeMyTrip-GoIbibo, Redbus, and there is another brand, Red Rails. It's a new one. So very diverse set of products and services across the travel e-commerce space. And it also has a travel fintech sub-module within it, like it's a sub-arm, or it's called Trip Money. So there are many fintech-related problems as well that we solve. So it's a very diverse set of problems and large data. To give some context about like the traffic and how is it relevant for the Indian market, roughly about, let's say, 200+ million users. A lot more are actually digital. They use internet and all, but then 200 million plus e-commerce use the e-commerce space. Of that, let's say 40 to 50 million are daily users, especially in the travel space. And within that, again, MakeMyTrip-GoIbibo and Redbus together has a substantial market share. So there's a lot of traffic, a lot of clickstream data, a lot of volume, right? So any improvement which we do, even a small fraction, let's say 10% or 5%, at this scale, it kind of is massive. It adds to the bottom line substantively. So I'll start with the introduction of a few model forms of the systems that we have, just so that I can set the context. More so to tell that there are all these model forms or the systems are ancillary, supportive. It's not like a complementary. It's not like there's one solution that's going to solve everything, right? So from a ranking systems point of view, we have various model forms: learning to rank, graph neural networks, BERT for rec, representation learning, content-based, and so on. And in addition, we also have many other attribution models. For example, we use attribution models combined with learning to rank. There's some interesting workspace. And then there are, it's not surprising, we have many pricing discounting related data science projects, whether it's in terms of competitive pricing or whether it's in terms of understanding price elasticity or what kind of decisions we should make so that it is good for the customer as well as not kind of giving out too many discounts or losing the money on the table. It has to be optimal for both parties. And there are various other model forms of the systems in place. Let's say it's about risk modeling, whether it's about uncertainty quantification, ad tech recommendations or slot selection, causal inference modeling, because while we have a very rich A/B experimentation platform, everything cannot be experimented in this manner. There are circumstances when you have to work with the existing data where the distributions are not uniform. Multi-touch attribution, language understanding, aspect extraction, review ranking, and object detection. They're all different components at various places in the org. And we also have a few ancillary revenue generating products like, let's say, Fairlock or Rail Strip Guarantee or zero cancellation or travel insurance. And there are many decisions here, like many decisions in sense, what is the price that we need to select? What kind of product we need to offer? Which is the customer group? How do we need to, position it for them? So how are all these systems doing? There's been a learning curve, no doubt about it, but it has now it has come to the stage that most of these systems have improved the business revenue metrics, conversion ratio, or the funnel metrics, so that overall we are going towards a journey where it's all personalized, more relevant, context specific, and ideally in a decluttered manner, so that the customers also like the experience and love to come back and do increase the repeat purchasing frequency. However, there are some problems. Often we find, not in every case, but often we find that the offline metrics are not, or directionally, are not in sync with the online metrics. For example, if there are, let's say, 3 models, you deploy something, the model rank as per the offline metrics, it's, let's say, 1, 2, and 3. Offline metrics like accuracy, conversion, NDCG, or maybe the expected profit or various other things. It need not manifest in the same manner when we look at the online metrics. And is this an experience of only MakeMyTrip? No, not really. Many e-commerce companies and others also have experienced the same. So on the right side, I have borrowed a slide from one of our competitors. The axis shows what is the model performance on offline metrics, the x-axis, and the online metric like conversion ratio, how much lift that particular model has brought in. Ideally, you will expect everything along the diagonal, but do you see anything along the diagonal there? No, it's all over the map, right? So why does this happen? Why is this that often there tends to be a gap between what we develop as modelers offline versus when we deploy it, how much lift or how much business impact we indeed see. So there are a few things which are quite obvious, it has become obvious now. Let's say in terms of data drift or concept drift or label drift. Each of them affect in their own way of how the impact is reduced, or let's say the coverage is reduced, coverage in terms of how effective your model is, or maybe the entire the personalization or entire recommendation itself is off the mark by a big margin, because the way you have prepared the data, the way you have trained the model, there can be a huge set of differences. Of course, besides this, there are other problems as well. So for example, training data biases. This is something that probably we cannot avoid, because the way the data is generated, it will have its systemic biases. The current systems are generating it. There are models and algorithms to correct. There are other problems, data quality issues. I presume many of you would have seen these data quality issues. There is a lot of maturity that has come, but yet I think that's not a completely solved problem. And then there are other areas like model training versus inference differences. So you train the model, but there is a big difference between, let's say, the model training process versus the inference data that you get in. And it could be of many reasons. So there are ways to correct and monitor all these systems, and ideally move towards systems which are not offline. If we train models or do things or have some checks and balances which make it more online or more frequent training, it'll help correct for some of these issues, not entirely. Okay, I think this is not necessary. It's just a flow to indicate the static learning. The key point is that often we take the data sets from existing systems, build models, and then deploy. And there's a typo on the right side. It's the API, not the data sets. And then from the API or the inference steps, we kind of make our recommendations. But then how frequently do we use this data to update the models? Many organizations may not keep this process very mature, rigorous. Even within a data science team of, let's say, 30, 33 people, I see there's a varying degree of attention that individuals pay to, let's say, a particular model or this aspect of the model or the applied data science part. So what can we do? A partial solution is, as I said, reduce the gap between training and inference as much as possible. And as a stakeholder, as the owner of this platform or the entire charter, to make a business impact, right? Remove the technical debt, at the same time also make business impact. I need to keep measuring all of these metrics. The more we measure, I'll be able to monitor and then help the teams in a right way. So it kind of now leads us to how to make this more cyclical or feedback loop driven instead of an offline process. So the various methods like frequent offline learning or offline or online learning methods, and continual or lifelong or incremental learning. Continual, lifelong or incremental learning is not oriented for this particular problem per se. It's about primarily how humans learn. We don't learn each and all the tasks at the same time. Let's say to classify, let's say 2000 objects, right? We learn tasks in a sequential manner as we grow. So the idea is that how can we build these systems where we learn tasks sequentially, and it has its own flaws, primarily in there's a risk of catastrophic forgetting. So we need to add knowledge without forgetting what we have learned before. And there are various algorithms for this. This is a very, many of you may know, it's a very rich area for research, right? So will this suffice? So I would say it won't suffice because of a few reasons. So till now, what we have talked about is, let's say we build a model and the premise is that the model or a function approximator is pretty accurate, but it's not true. These are all point estimates. We don't know, or at least haven't talked about how do I assess the uncertainty around my model, or about the data or actual relationship between, let's say, the features or the data and then the outcomes that we're trying to model, right? So there's some uncertainties. How do I quantify? Then there are other situations where you may not even have data. Let's say there are many decisions that you want to take, you want to experiment with, but then in the existing data, you may not have them. Like it may be various price points or the way you want to customize your UI. You may not have experimented everything enough. So how would you know how would you know that the data that you have is good enough for me to learn and experiment further? So if I think about different model forms or the approaches I can think, right? One is, of course, the supervised model, supervised and unsupervised machine learning models. Just give me a second here. Then the other methods would be to use causal models. Why do I say causal models? Because it's not feasible in every situation that you have experimented all the choices or the options or decisions and the distributions are uniform. It's not, more often, you can do an A/B experimentation, etc. But there are situations when you may not be able to do that, you don't have that data, then you need to do some kind of a causal modeling to account for all the other factors, right? And it will give you some cues as in, okay, what kind of decision I need to take. But in a perfect world, if you have infinite data, the best way is to do a A/B testing, test it out for a small sample, and then continue to learn. What is better than A/B testing? If instead of an A/B testing, then multi-am bandits, that's the type of a framework that comes into picture, where you say you don't do the A/B testing and just look at point estimates. You set up systems so that it will automatically help you learn what is a better decision, what is a better decision set. And then subsequently, if you extend that argument, what is the, we may say, okay, what is the decision that I need to take that is good for not just the immediate outcome that I'm going to get, but also subsequently down the lane. Can I account for that? Maybe I will discount it. So that's where like the discounted returns formula comes into picture, like a Bellman's equation and all, and like a full reinforcement learning kind of framework comes into picture. And let's at least cover the multi-arm bandit and then the framework part of it here. And maybe later we can take about questions about what are the challenges that come up in this, and also what are the challenges that would come up if we try to train, let's say, offline or online reinforcement learning for this kind of e-commerce setting. So just to add one more circle to the picture for this ancillary and or complementary frameworks, that would be the RL and the bandit. So that would not be the only unique solution, but that will be one more tool or a framework in your kitty to solve many business problems. So I put a lot of jargon here. Hopefully I'll be able to, rather the text, I'll be able to cover each of this bit briefly. Maybe I think it's appropriate to ask a question here. How many of you have worked with multi-arm bandits before? Okay, that's good to know. Okay, so let's start with what is the primary framework. So we discussed about that through this machine learning process, right, or applied data science process, it'll be ideal to hook our metrics or the model learning process to a feedback loop, right? That's one of the things that we discussed. So that's what we're describing in here in the graph, that there is an agent or a decision system that is spinning out recommendations given a particular context, recommendations or decisions, choices, and you pass to the environment. Environment will be your backend systems or the client side app, if it is defined or if it is abstracted out to consume it in that manner, or it could be some other systems. It could be ranking, pricing, content selection, or something else. And then we get a feedback loop. What is a feedback loop? Basically how the customers react to this. There are many customers of various diverse form and they have different types of needs. For example, in travel e-commerce, you can think of those who are going to travel from, let's say, Bangalore to Delhi versus somebody who's traveling from Delhi to Dubai. The type of needs would be very different. Also, somebody who is traveling solo to a particular hotel, let's say, the type of amenities or the facilities they are looking for is different from, let's say, somebody is traveling with, let's say, 2 kids, family and 2 kids, right? So the needs are different, and based on that, the way they respond to the decisions we make will be different. So the idea is to kind of learn in a context-specific way. So what does this kind of a framework where there's a feedback loop provide you? So there's a provision for estimating uncertainties, especially the multi-arm bandits, and some form of reinforcement learning methods as well account for this, or have a provision for uncertainty quantification. You can also add contextual information, as I said, for example, the nature of the customer or the demand or maybe other type of data points. There are different modules which are varying from simple modules to very advanced, nuanced versions as well. And what is the outcome that you want to keep in mind? Let's say if I'm training a machine learning model, let's say some a ranking algorithm or a particular prediction model, I'm going to use, let's say, NDCG or some kind of accuracy, F1 score or precision recall kind of metrics, and improve that in the offline dataset that I see. But I have not yet hooked that directly to the business metrics, right? Because the business metrics would be conversions, number of bookings, how much is the total revenue I'm going to get, or at least the CTR, and what is the quality of the engagement that the customers are going to have. But in this particular framework, we can hook it to that, because we're going to measure that as a, if not a primary outcome, but at least as an intermediary or subsequent outcomes, and try to kind of learn. And then there are, and what is the other thing that this brings into picture? Compared to, let's say, an A/B testing, right? You do an A/B testing, you have an entire framework, you test it out for a while and then infer. But here you can have many more options to test out and get data that can be used for subsequent model forms as well. For example, Imagine if you want to think about, okay, what is there's a particularly interesting problem. As the fares change in travel e-commerce, right? Fares change because there's a supplier data comes in. We can't make too many hits. If we make too many hits, that will put too much of a load on the servers. So we need to optimize that. But now it has a downside as well. The more and more customers see that the prices are changing, they'll be dissatisfied, and then they may not make the booking, they may drop off. So I need to balance this. And there's no way for me to do a A/B testing to think about or learn. Indeed, is there a true relationship that, okay, if the prices change, there is a negative impact, or it's a vice versa? That it could be that it will give a sense of urgency that the prices are rising, and hence the customer should actually book. So we don't know. So when there is no A/B testing, then I have to rely on all the other causal models, attribution models. There are many versions, linear, non-linear, many things have come up now to kind of infer and draw insights. But if we have this kind of framework where I can experiment, I can rely on the data and directly tabulate it. In fact, I don't even need to tabulate. The objective is to have a framework which will automatically learn what is the better decision, right? And scale, of course. It's highly scalable. Yeah, so what are the two important principles if we talk about bandits, contextual or multi-arm bandits? I mean, by the way, some of you may be wondering why it is called bandits, by the way. A long time ago, the notion was that if there is a gambler or a one-armed bandit who goes to a place, a slot machine or a vending machine, and slot machine, he's thinking about how do I maximize my reward? What are the different arms that I need to choose? I don't know which one is the best, but I need to experiment one at a time, enough to some extent, such that I know that this is the best arm that I need to choose, and then I'll get the maximum reward. And that's where the terminology comes from. So as I described an example, right? So there are two parts here. One part is to explore, try out a few things and then learn which is better. But that's called the exploration phase. Then the second part is exploitation phase. Exploitation is, okay, you learned something from the data, so now try to make use of it. Choose that arm more often because that's a better arm or a choice, right? So from a modeling methods and techniques point of view, there's a big list of them. I mean, starting with, let's say, simple Thompson sampling, upper confidence bound, epsilon greedy, linear models, linear Thompson sampling, and we can use a neural network model. On top of it, add a linear Thompson sampling, or we can use a Bayesian neural network models or a Bayesian regression models as well, because they facilitate this. They facilitate estimation of uncertainty around your parameters or about whatever the expected outcome is, right? And what kind of libraries you can use? I mean, we can code this in Python and PyTorch or TensorFlow and all, or even NumPy, honestly. But there are many libraries which facilitate or make it easy for you to kickstart, because there are various algorithms and you can try with to see which one is more suited for your data set in terms of uncertainty quantification, which one is more suited for your problem. Some of those decisions could be like a single agent problem, some of them could be multi-agent problems. So the idea is like you need to explore these options, and again, as in explore, exploit, you need to figure out which one is more appropriate for you. Okay. So I'll try to skip through some of these quickly, so that we can focus more on the use cases. But I'll give a brief introduction about like what are the type of simple, give a very simple example just to illustrate how a multi-arm bandit works, right? So imagine you have 3 choices. Okay, it could be discount levels of percentage A, B, C, or it's about choosing the color of a button, whether it should be red or some variant 1, variant 2, or slot selection, whether the ad slot should be shown in 3rd rank or the 5th rank or somewhere else, or the content selection as well. The more the number of choices you have, of course, it'll become complicated, but here using an example of 3, you start with 3 choices. The first one in the top corner, right? And to the left of that, it says you don't have any information about it. So you're going to randomly select one of these choices and then measure what is the reward. And that's where different algorithms come into picture of how you would fit this expected reward. But one simple way to use would be to use a beta distribution, Thompson sampling. Beta distribution helps you to quantify not just the average reward, but also the uncertainty around it. The more and more data you throw in, you can be more confident about your assessment of what reward you can get. So as you try more and more, you get to know that, okay, so there's one arm which is much better than the rest. But prior to that, you don't know. There's a lot of uncertainty around it. So you sample, you still try to explore. You explore enough such that you're sure of that the which arm is better for that context, right? Then there can be other model forms. So for example, if you use in a supervised context, you may want to predict some particular outcome. You can predict it, maybe a linear system or maybe a neural network model, primarily to capture, let's say, all the interactions, and also because there'll be a lot of multi-collinearity. So if you use a linear system, the uncertainty estimates will be could be off the charts. So it's better to kind of have some function approximator which helps you account for that in a more better way. But what do you do with that? So you can stop at one layer prior to that, let's say last but one layer. So that's again a vector representation. And on top of it, you can have linear systems or other systems which account for this uncertainty as well. Well, there's one more method in the same framework. I'm not included a slide for that. If you train, many of you would have used dropouts for regularization or dropouts for, helping your model not memorize but generalize, right? So we use dropout while training, and in the inference step, we rescale, and it's taken care automatically, right? But we don't turn off the nodes in each layer, even in the inference step. But there is a theory that we can use dropouts even in the inference step. You do this multiple number of times, and you get actually a distribution around the estimates, predicted values, and the uncertainty around it, right? So you can use that method as well to make your decisions more robust. And then the Bayesian neural network method, of course, because which it will facilitate not just a point estimation, but a distribution around it. Instead of just a linear weight vector, you'll have a weights and then the variance covariance vector around it. So the uncertainty, at least one type of uncertainty. There are various types. One is called epistemic uncertainty, and the other one is alloteric. At least one form of uncertainty you can account within the model, and you can use that to kind of explore and explore the various choices that you have. So what happens if you don't do a good job of estimating uncertainty? So I just want to call it out because it has a huge bearing, right? So we think that, okay, so these model forms will help you make better decisions, but it's not like plug and play. You need to have good ways to account for some of these problems. Why is that so? Suppose if you, let's say there are 10 choices to choose from for a particular group. You over-explore all these choices, and some of the choices could be really poor, right? Then obviously you are choosing it more than optimally, so the business reward would come down. Under exploration of good choices also will make it will delay the process. You'll learn the which is a good arm slowly. High plasticity, for example, in the model, the way that you compute the features or the inference step, the gap between inference and the model training, if there is high plasticity, then again the terms that you have learned may not be even relevant. Now, if you have, let's say, over elasticity, or if you tune your model to be too agile to the existing data, then again the catastrophic forgetting kind of situation could come up, and again you may end up exploring more than what is optimal. So you need to fine tune this so that it's reasonable enough for your particular problem. That's where again the skilled data scientists or the domain knowledge comes into picture. So what I think about this is like, so would a new model or a methodology suffice? In my opinion, no. Probably no. High quality data will continue to be key, so you need to pay attention to that. Tools and methods will help you be more productive. Your data science team members be productive. So there's a saying, right? Like what gets measured gets improved. So if you measure something, you can improve. If you can't measure this, you can't even say that, okay, you can hypothesize that I need to improve, but you don't know by what direction, by how much you need to improve. So that's a philosophy I take in this applied data science, because we need to keep an eye on the business metrics as well and improve these. So that's where the platform comes into picture. How do I kind of create this platform or a framework which will make it easy for data scientists, product managers, category, revenue management, and various folks to do multiple experiments. So the font is too small, but I'll try to go through some of these aspects. On the left side, I have just indicated that the app and then various decision-making systems. It could be ranking, pricing, content selection, and other decisions. And there is a particular API or a particular service which can render recommendations, and there are downstream customers who can hit it. It could be backend systems or front-end, more often probably backend. Then there should be appropriate logging. We use Kafka and Athena, S3 data lake, and various other forms to maintain our databases and analyze them and learn. So if you're pushing your data decisions to Kafka, and even the infrastructure is set up to kind of push it to S3 data lake or via Kafka, then you can use Spark streaming or Flink streaming or many other methods, and then join them and then learn. Given these are the decisions, what is the outcome that I'm seeing? What is the reward? And then help improve your model. And there will be situations where more often probably that the feedback is delayed. You make some decisions now. It's not like customer is going to book right in few minutes. They may come back, they'll think about it. Maybe next day they will come and book. So there's a delayed feedback. So some of these systems may not be necessary, like reading and doing everything real time. Some of these being semi-real time may suffice our needs, right? And then you need to have some kind of a configuration UI so that you can control the configuration of arms and decisions, etc. Because it's a learning process. You'll start with something and then you want to change those decisions later. And then you don't want the experience for your customers to be haphazard. You don't want to change your decisions very frequently, right? So there must be some kind of a stickiness to ensure customers have a seamless, consistent experience. So there must be some layers in your system. That's what we have. And then just a model repository where like various data science team members come and build the knowledge so that other data science team members can start from a better place than instead of, reinventing the wheel. This is just an abstraction, trying to create handlers and layers, etc. So that we can use various model forms in a more plug and play manner. There is obviously a lot of effort has to be set in to train the models, etc. But at least some part of your problem you can solve. You abstract your layers in your platform. So how many modules do we have? So currently on this platform, we have about 6 to 7 projects. Some of these, one of these projects or a few of them have many modules. Modules could be AP or how many days ahead the customer is going to come and book. That could be a group, context group. Or each of these flight sectors could be group, or different cities could be different groups, because the model has to learn in a context specific way. So currently there are 500 plus sub modules or learning systems. And yeah, the number of decisions we make today, as we literally speak, maybe 6 million decisions or more per day across a few projects, about 6 to 7 of them. And I have a bunch of other projects lined up. Because we have this platform, product managers or category or revenue would feel confident that if I want to start an experiment, it won't take like ages. It will be agile, and I'll be able to measure how these decisions are doing and also help the data scientists to fine tune, improve it. So I'll go through some of these examples that we have, and then we'll probably take questions after that. Yeah. So before we get to scenarios, there's one more lever that we have. Uh, yeah. So in this system, when we spoke about agent or agents that are spinning out recommendations, right? What is the objective? What is the feedback that you're going to take? Is it a single objective or a multiple objectives? Do you have, sometimes you'll have multiple objectives that you need to pay attention to or balance them. So that's again, it's very important for your business. You can't undermine one for the other. So do we have a different agents for each of these? Agents or modules for learning, or you have a single agent, but that can take into account multiple objectives. That's the theory, that's the framework that we required, and we added some modules for that. Yeah, so just to illustrate a few problems, right, where these kind of scenarios come in. So yeah, one of the problem that came up for us is, okay, there are current ranking algorithms that are going to learn what is good for the customer, which hotels are appropriate, more relevant, and then we show them. But it's possible that there are hotels which are, let's say, not placed well because they're historically they have not built up the brand or the trust, or the pricing was off. But now they have come forward and say, "Oh, I'm going to give a steep discount. I'm going to give something really useful for the customer. So why don't you, do justice to that? Give me more coverage. Give me more impressions." We need to do it in an organic fashion. We can't just boost it up and reduce the customer, give a poor quality experience, because it could be a bad hotel, right? So we need to do it in a manner such that that is appropriate for that particular high opportunity hotels, that it improves the CTR, but at the same time, overall customer experience is not poor. It has to be good overall conversion. So there are multiple objectives. Sometimes it could be conflicting, sometimes it will be correlated positively. Slot recommendation. So there are ad placements. Ads more often are relevant to the category, the problem that we have, but there are significant chunk of cases where the ads are not relevant. If you show the ads right at the top, obviously we'll get more impressions, more revenue, but that will negatively affect our core business as well. So we need to kind of figure out what is a reasonable place, what is a slot selection, and such that it does justice to the ad impressions, at the same time also keeps our overall funnel metrics, overall customer experience healthy. And similarly, there are a few other problems in subcategory recommendation, selection, content selection. Even in a ranking system, there'll be sub problems. Hotels which are, let's say, if I take an example of hotels, not the flights, hotels is much more complex space and there's so many choices. Hotels that are clickable need not be bookable, or those hotels which are bookable need not be clickable. So there'll be some correlation, but need not necessarily be, perfect. So what do we do in these kind of cases? So there are different methods you can think about. One method is very simple. You know a priori how much importance you want to give for one dimension than other. You do a weighted average of that and then learn. There you need to keep in mind that the scales could be very different, scale of reward or scale of objective that you get in each of the submodules. So you need to do appropriate rescaling, etc. Other one is, if let's say the category manager product says, okay, I don't know at this point how much weights I need to give. Then you can assume a set of vectors, weight vectors. Let's say there are 3 objectives. Let's say you can have W1, W2, W3, like that, different vectors. And you can choose these vectors and then experiment with it and learn. And that there are various methods within that, linear, Chebyshev, scalarization methods, etc. And then the other one is pareto frontier. So in a 2D example, it's simpler to think about as in the right side. So if there is one reward 1, reward 2, these are all, each of these dots are decisions, right? Those are and the points are the expected outcome, expected reward. What you want to do is select decisions which are on the pareto frontier. Pareto frontier, so that the decision is not inferior on both objectives, let's say. It's good either on one or the other objective, or both ideally. So that's the premise. So that worked for us in many cases. Yeah, so let's talk about a few scenarios and where we have used this platform, multi-arm bandits, these algorithms. So ad selection, as I said, impressions we need to improve. While improving impressions, we also need to pay attention to CTR and then the funnel metrics. So the scales are very different. Ad revenue is not similar to the core business or the core revenue. So we can't kind of think about scalarization methods and account and presume that we're doing justice to that, because it may not the weights that you assume may not be appropriate. A priori, you may not know what is a good set of weights you need to assume. So you need to experiment and then choose something which is optimal. So it improved our ad impressions by 6%. That multiplied by the various touch points, 50 plus touch points, MakeMyTrip-GoIbibo, Redbus, 3 brands, and the lines of business, flights, hotels, rails, cabs, and all the other lines of business. And within that, there are multiple funnel steps, etc., where this less intrusive, but still ads are shown. So it adds up to a substantial revenue, right? Another scenario, direct hotel search. So customers come and search for in a particular city, and there are ranking algorithms, as I mentioned earlier, which generate what is the appropriate rank for this context and for that customer in this search in this particular trip. However, when the customers make up their mind and do a single hotel search, it's possible that the hotel may be sold out, or it could be that there are many other options that we could show which are similar to that hotel and the customer may want to consider, right? And it may be good for the customer because maybe the pricing is appropriate or even better, who knows. So what kind of algorithms we have here? So given this is a similar like item to item kind of situation, we use graph neural network embeddings, content-based embeddings, representation learning, and then even metadata as different module. And then there is a pre-trained ensemble on this. So imagine now there are these 4 choices I need to choose. One would say, okay, so wouldn't the embeddings be rich enough that it is good for your every other scenario? Answer is 90% of the cases it is true, but there are 10% cases when customer is looking for more a particular type of a quality of a service or a quality of a hotel or a resort or some other aspect. So they would pay attention to the content, not the price, right? And in those kind of cases, maybe that particular model is not appropriate. There's other model, those are more appropriate. So what we found is that indeed the model selection varies. So the choices varied across data or the context. And how did we do that? We had set this up in the platform and we trained a neural network model first, and then on top of it, a learning module. And then we let it learn. And over a month or month and a half, it automatically converged. And when we look at it, we do see that the decisions are different across contexts. And that's insightful, useful. And it helped the conversion ratio improve by 1.5% or so. And that's substantive if I think about the total scale annually, consistently if it is statistically significant. And then pricing experiments. Probably, yeah, I think it's quite obvious when I say what is the pricing, discounting kind of coupon experiments one could try and learn, right? And then there is a content layout contextualization. This is something, just to give you context of why it is relevant for Make My Trip. Maybe you can connect the dots. So this is a screen where I've just searched for Goa, one of the dates. So there's a lot of content on your screen, right? You show the filters, you show the hotels. Hotel ranking is solved using other algorithms, but there are various other elements. You select the content, you select pictures, you select what is the type of relevant information you need to show to the customer, whether it's a messaging, whether it's a label, even the colors, in fact. And so this is like the entire canvas you have, and you need to optimize or need to make it as good as it can for the customer. Have a seamless experience and then it be relevant as well. So there are many touch points here, many choices being made here. Today there are many rules for this. Domain specific knowledge is there, but with that there are rules. However, it can be improved. Let's say for images, for example, some hotels could have 200, 300 images, and now which is the right image to show, right? So you can use pre-trained models, let's say neural image assessment score, aesthetic score, or the type of image that I have, whether it's about a facade or a front end or the overview, or it's about a room, you can use some algorithms to kind of converge or reduce your set to maybe 10 images or 20 images. But then within that, which one will you choose? That's where again you can experiment, right? You can experiment and see which is the one which is more appropriate that particular hotel, and in that context, and then make decisions. Similarly, messaging, persuasions, there'll be so much content. Somebody may be looking at a resort or a hotel with as a swimming pool, and somebody else may be looking for a hotel with maybe a play area. Someone would be looking for maybe a hotel with a good restaurant, so that I can use that. The needs will be different, and how do we kind of figure out all these? We may not have tested all these in the existing system to learn, and that's where again this, instead of an AB, a multi-arm bandit or a platform comes into picture, which will make it easy for you to experiment and learn. That's it. I think I hope I was able to give you a few examples and cues of why we build this platform, and how it has helped us in making better decisions.